Hello, everyone, and welcome to the inaugural meeting for the Cluster API effort, which is part of SIG Cluster Lifecycle. Today is Wednesday, October 18th. And since this is our first meeting, I think we're going to get started by just sort of talking about what we think we're doing and why everyone's here. And I'm sorry that my camera doesn't work. It worked at the meeting 2 hours ago this morning using the same software, and it appears to have broken since then. There's nothing I can do to turn it on. So I think maybe to start, we'll just kind of go around and if people want to introduce themselves and talk about why they're here and what they hope to get out of this meeting in particular, or of this effort, that would be useful. So I'll go first. My name is Robert Bailey. I'm listed as Cluster Ops in Zoom so that I can record the meeting. I work at Google, and I'm one of the leads of the Cluster Lifecycle SIG, and working on the Cluster API effort because I think it's important for us to standardize not just at the sort of kube admin level, but also at the level of specifying what clusters look like to meet a number of different important ops cases. I'm just going to go across the top and sort of call on people. Chris.
Which Chris?
Oh, sorry, Chris Rousey. You were next on the list.
Okay. Let's see. I'm Chris Rousey. I'm also on the Cluster Lifecycle team here at Google, and I'm mostly interested in the control plane definition in the API group. I'm curious. I want to see this effort become a standard way to deploy and make it easy to automate and maintain and operate clusters. And I think getting the control plane definition just right for continuous operation is one of the most critical pieces for that.
Cool. We'll go to the other Chris now. Oh, and we cannot hear you, Chris. I can see that you're unmuted and that your mouth is moving and that you're waving. All right, Jacob, why don't you go while Chris starts to fix something?
Sure. Hey, I'm Jacob Beecham. I'm also on the Cluster Lifecycle team at Google. I'm most interested in the node portion, the declarative node portion of the API, and interested in the project for all the same reasons as the other Googlers.
Rodrigo.
Yeah, I'm Rodrigo. I'm on the App Engine Flex team at Google. I'm just interested generally in this space. So just kind of listening and learning about this space at this point.
Thanks. Alex?
Sorry. Hi, Alex Moore. I'm also at Google on the Cluster Lifecycle team. I manage it, so I just thought I'd tag along and see what's going on. My particular interest is really about making the cluster ops experience better, right? And I know we're focusing on deployment and such initially, but that longer term life cycle of keeping clusters happy and running and so on, we can do better than we do today. And this is a path, I think, to get there.
Thanks. Chris, let's see if your mic's working.
Can you guys hear me?
Yes, success.
So I'm Chris Nova. I work at Microsoft. I am involved with SIG Cluster Lifecycle, COPS, and I wrote Kubicorn, and now a lot of other people contribute to that project, which is great. And I believe that the fact that we don't have an infrastructure API is hard for me to swallow. So I really want to see this thing take off, and I really want to fight for it. And I'm going to devote a lot of work time and a lot of personal time into this effort.
Excellent. Fang.
Hi everyone, this is Feng. I recently joined the Kubernetes team at Google, so I just trying to help wherever I can.
Thanks. Matt B.
Hi there, yeah, I'm Matt. I'm from a UK company called JetStack. We focus entirely on Kubernetes. One of the things we've been doing recently is working on a sort of cloud agnostic Kubernetes provisioner based on some of the work that we've previously done with some of our customers. We open sourced that last week. It's Tarmac with a K. And we adopted the Cluster API, or at least the very early humble beginnings of the Cluster API work that Chris has done. So keen to contribute, really. We've got some feedback of our own based on what we've put out. And just keen to be here and listen in and contribute where we can.
Awesome. Yeah, Chris was asking if there's a link to your project. Can you stick that into the meeting notes?
Yep.
Thank you. Cole.
Howdy, I'm Cole. I work for CoreOS, mostly planning to be a fly on the wall for these discussions. I have been involved in far too many Kubernetes bring up tools, and I would love to see some standardization for at least the entry point for it. So,
Awesome. Maroon.
Hi. Oh, never mind. Screw video.
I can see the top of your head.
My name is Maru. I actually work on the SIG. I work on Federation for Red Hat, and I was just kind of curious how this sort of tied into the cluster registry thing that some people at Google have started. So I'm just flying the wall for that, I guess.
Cool. Jessica.
Hi, I'm Jessica Chen, also on the Cluster Lifecycle team at Google, and I'm here to help out.
Awesome. I think I got everyone. Please poke me if I missed you and you'd like to introduce yourself. I kind of wanted to start by going over a pitch deck that one of our PMs helped us put together for sort of why we wanted to start working on the Cluster API. Hopefully this resonates pretty well with people like Matt, who sort of started on this effort themselves. And Jacob was nice enough to share his screen since I'm doing the recording. And we'll just sort of walk through this really quickly. I know a lot of people have probably seen something like this, or this will not be a surprise. But I just kind of want to set the stage of where we think we're headed. So if you go to the next slide, the current state of the world for cluster management and cluster ops, as Alex mentioned, is very fragmented, where we have lots and lots of different tools, right? Chris Nova mentioned that she'd started Kubernetes, and Cole mentioned that he'd been involved in lots of different tools. And there's sort of been a flowering of different tools in the community over time, as we haven't had any agreed upon definitions of what it means to describe a cluster, right? We've explicitly even said that that's not part of core Kubernetes. Justin Santa Barbara sent a pull request a couple of years ago to try and put the notion of node pools into core, which was rejected. And as a result, sort of everybody has re-implemented things like node pools. People are implementing different types of upgrade strategies. There's not any consistency in terms of cluster configuration for admission controllers, et cetera, across different clusters. And as a result, we don't have a foundation to build higher level sort of cluster management or cluster ops tools. So things like the cluster autoscaler get re-implemented. And talking with the cluster autoscaling team, they've actually started themselves also sort of implementing something akin to like a cloud provider interface, which is what we're trying to get rid of in core, / like a cluster API definition interface that is portable across clouds. So I think what we're starting to see is lots of different people are stumbling across this same issue. And if we can sort of solve it once and in a good way, we can reuse that across many different parts of the ecosystem and get a lot of value out of it. Next. So the cluster API is meant to be a declarative way to create, configure, and manage clusters, where we have controllers in the Kubernetes sense of controllers that'll reconcile desired versus actual state. If you think about a lot of the existing systems, this is sort of how they're built. COPS is built this way, GKE is implemented this way, Kubernetes is built this way, and so we want to sort of just standardize on what those look like. Cloud providers would then implement support to sort of glue the cluster API onto their particular infrastructure as a service that underlies the cluster API. And we would then start porting existing tools like the autoscaler to work against the cluster API instead of to the cloud provider APIs directly. Next slide. So sort of from a diagram point of view, what this looks like is you'd have a user interacting with the deployment tool. The deployment tool uses the cluster API plus this sort of glue layer that I mentioned to actually instantiate a cluster on top of it in a different cloud environment. You then have cluster automation that can be pointed at the same cluster API, so that the cluster automation can introspect what the different nodes look like, what the pools of nodes look like, can automatically scale or add nodes to the cluster or remove nodes. You can build things like cluster repair or monitoring that also targets that and is able to take automated actions built on top of the cluster. The next couple of slides are just sort of straw man, rough estimations of what the API might look like. all of these are just sort of here to point out the fact that we've started thinking about what this would look like in terms of structures. And then the resulting sort of YAML that you'd get would be something that is going to look pretty familiar if you've had to deal with Kubernetes YAML files, but instead of describing your application, would describe your cluster. So again, those are all just sort of straw mans, not meant to actually look like the real cluster API, because we've actually started making progress past those initial sort of straw mans since they were written up a couple weeks ago. From the user point of view, what a user would see is they might have different tools that are customized for different environments, but where you actually end up with clusters that look the same. So you can take the same cluster.yaml file, run it through different tools to create clusters, and end up with clusters that look the same in the end, right? You might end up with two clusters that both have an HA master configuration and 3 one-core nodes, but in different environments. And then after that, you could use the same tool on both environments to do things like scale a cluster. So you'd be able to add nodes, or you'd be able to set the autoscaler to increase the node count on both environments using the same tool, right? So deployment might be specialized tools for different environments, but once you've deployed and you have the cluster API in your cluster, you can use consistent tooling after that. So some example features of where we think this might be useful are for doing sort of multi-cluster operations across clusters in different environments. So if you have 3 clusters on-prem and say 3 on Azure, you can define a rollout strategy where you're going to roll through all of your clusters and do upgrades over the course of a number of days. And you can sort of cobble this together yourself today, but you have to write sort of glue that sits on top of the fact that in each different environment, you've most likely used a different tool to create your clusters. And what we want to encourage is, even if you're using different tools, you can use the same ops tools on top of those. And then likewise, I've chatted some with Alexis from Weaveworks, and he's been espousing something that he calls GitOps, which is basically you check all of your configuration for your applications into Git, and those get automatically reconciled into your clusters. And so you use your version control as the source of truth. And you can do the same thing at this level with your clusters themselves. And you can check in your cluster definitions and use those to be the source of truth. Weave actually does this today using Terraform. They check in Terraform configs into Git and use that to describe what their cluster should look like. And that works great for their environments, but again, is not portable across environments and across companies and across infrastructure. And so with the cluster API, you'd be able to make that sort of that GitOps workflow work across different infrastructure. So some risks that we see are that the API design here is going to be pretty tricky. We can't make the API so generic that you can use the same YAML everywhere, but you can't actually expose the underlying power of different environments. And conversely, if the API is so specific that it works great in one environment, but not others, or you can't actually extract the general pieces out, then it's going to become really difficult to make things that are truly portable. And a good example of this is the cluster autoscaler. If your API is so specific to one cloud, or if the cluster autoscaler has to be re-implemented to know very detailed information about specific cloud implementations of the cluster API, then it's not actually sort of portable in the way that we want. The second one is community adoption, where everyone today is using one of the tools that we talked about on the first slide, and has sort of grown preferences for how they configure and manage their cluster through that experience. And getting people to consolidate on sort of a new way of running their cluster through a consistent API is going to take some work and some effort. And then finally, it's been a long time since people have started thinking about this problem, but nobody's really pushed hard to make it true. And the longer we wait, the harder it's going to be to drive people to consensus into a standard. And then the last slide is talking about so what we're doing from the Google side. So you guys probably noticed that there are a lot of Google people on the call today. We have a number of people that we're spinning up on this effort to make sure that it makes some significant forward progress. We've started working on a spec. We want to share that spec and start getting feedback, and especially for people who've also sort of tried to do this. And we're starting to build a prototype against that to run on Google's cloud. We hope that people will do that as well on other platforms. We're looking to figure out what tools that we can port to sort of prove out the cluster API in the near term. And the last bullet here, I convinced our PM to resolve that. And so that's no longer an open question. It was when we wrote the slides. but the code is going to end up in the kube deploy repository. I just merged a PR like an hour ago to create a directory for the cluster API, and we can start putting everything there. The nice thing is it's in the Kubernetes organization. It's got the CLA bot attached to it and so forth, so that we know that contributions will be covered sort of legally going forward in the same way as the rest of Kubernetes. So I rushed that pretty quickly. Do people have any questions, comments, concerns?
So kube deploy is going to be where the Go code lives, potentially, that we would be consuming?
Yeah, so the idea is to put it there for now until we have a better home for it. So the problem is right now, with the sort of recent election of the steering committee, the incubator process has been put on hold. The process for creating new repositories in Kubernetes has also been put on hold. I talked to the Cluster Federation folks last week, and they have their own repositories that they created like 2 days before that hold was put in place. So they kind of squeaked by having their own cluster registry repository. But at this point, new repositories are not being approved. And nobody's graduating from incubation until the steering committee figures out sort of what that whole process and procedure should look like. And so Brian Grant had recommended that we sort of squat in an existing repository. Kube deploy is almost completely unused at this point. And we can sort of use that as a reasonable home for now.
Okay, awesome.
But the intent is not for it to live there forever. That's just an intermediate step while the steering committee works out some processes and we can argue for a more permanent home.
I had a couple questions about scope. It seems like there's potentially a massive, huge scope here, especially if it includes things like doing cluster upgrades across clouds, considering that's a problem that virtually no one has solved, even for like single clouds. And I'm just curious what the explicit goals are. Is there a goal to homogenize the top level input? It seems like that's something that everyone agrees upon. Is there a goal to make cluster portable between tools as well?
When you say portable between tools, what do you mean by that?
Like I deploy a cluster using tool A, using using kops, and then I decide that I want to use the new hotness kubicorn, and I want to use kubicorn to drive an upgrade now. Should I expect that my cluster is portable between these tools because I'm using the same API?
So I think what we'd expect is that tools that target the API would be portable regardless of how you would deploy your cluster in the first place. It's not clear that has the following implication that you'd be able to sort of switch tools on the fly. So say you use KubeSpray to deploy your cluster, and that sets up the cluster API in a reconciler that uses Ansible to provision and install new nodes into your cluster. Right. You couldn't necessarily just say, because it has a cluster API, I can now use kubicorn to provision and add new nodes to that cluster. Because when you tell the cluster API you want a new node, the reconciler that's running on that cluster is going to be using Ansible based on your configuration, right?
Yep, totally makes sense. Okay.
So it's possible that you could replace that reconciler with a new one that is the kubicorn reconciler and sort of switch midstream that way. But I don't think that's an explicit goal so much as the fact that the ops tools can be consistently used across clusters.
Yeah.
Okay.
The API is more of a I can replicate and not I can lift and shift. I look at
or maybe put another way too, the goal is not necessarily portability of deployment tools as much as it is add-ons that you might run in the cluster that need to interact with the cluster and know about the cluster and have a concept of a high-level view of the cluster. Is that fair to say? Because it seems like we're making a distinguishment between tools that actually deploy the cluster versus tools that operate on the cluster, like the autoscaler.
Well, I think to me those are the same thing. Going from 0 to 1 should be no different than going from 1 to n.
Yeah, that's actually exactly my concern, is that the autoscaler is probably going to need to know about some things that exist beyond the API as well. Like the autoscaler for Azure, for example, depending on which one you're looking at, both of them have dependencies that aren't obvious from the API level on how the nodes are created or how they're managed.
So let me try this and see if this resonates, right? Like kubectl is different from the cloud provider backing our APIs in the core Kubernetes, right? And so what I'm wondering is if this is a way of splitting tools into, I'll say, user-facing generic tooling that is the command line tools versus the cluster API backend provider. And so at least I don't know if it's possible, but in an ideal world, we would be able to make most of the provider bits be hiding behind the API, whether it's Kubicorn or COPS or so on. And you wouldn't expect to be able to shift between COPS as a provider and Kubicorn as a provider and adopt all the data structures of one versus the other. But if I'm a cluster admin monitoring these things, if I want to kick off an upgrade from version A to version B, maybe that's the kubeadm style tool equivalent that sits in front of this cluster API, and you can call it and say upgrade node 57 from version A to version B.
Sure, that makes sense to me. I guess I'm a little confused in reconciling that with the using the cluster API as an example, or using autoscaler as an example of why the cluster API would be useful. It sounds like you're kind of lumping in the autoscaler with the deployment tool there, which makes sense conceptually from what the autoscaler needs to know, but it seems to not necessarily make the best example then of what the cluster API would be usable for.
So maybe this would help. So if you have a consistent way to add capacity to your cluster, right? So the autoscaler is automation for adding capacity to your cluster. But even if I'm doing it manually and I say, I want to add 3 new nodes to my cluster, if there's a consistent way to say, create, kubectl create a CRD resource that describes that I want a new node with 1 core, and that at a high level can be made to be consistent across clouds. Then you could say, give me a core, and the fact that I'm running on Azure, the provisioner knows how to map that 1 core node onto an Azure node that it spins up and initializes and joins to my cluster. And I could run that same command against my GCP cluster, and the GCP provisioner knows to add a single core node and initialize it and add it to my cluster. Then the autoscaler effectively just automates that process, where it can look at the set of nodes that exist. It can say, if I were to add a node like this and run a simulation, this pod would now go from pending to scheduled. Let me declaratively say, I think a new node should exist that looks like this. And the provisioner for whatever cloud it's running on could add that node, and then the pod could become scheduled.
Okay, sure.
Does that make sense?
Yeah, that makes sense. I guess it just doesn't happen to be the way the autoscaler works today, but it makes sense from an ideal perspective.
Which is interesting because the autoscaler has kind of 2 responsibilities today. It not only decides that we should scale up and how large to scale up the cluster, but it also needs to know about every cloud provider that we support to know exactly how to create a new node in Azure versus GCE. And so it doesn't have this intermediary interface where it could just decide, I want to scale up and this is how many nodes I want, and then have a completely independent process actually fulfill that.
Yeah.
In a generic way, like specifically for, let's say, GCE, but in a generic enough way that it also works if I manually scale my cluster, or if I also have a specialized GPU scaler that knows about its workload aware for my machine learning workloads. And so we can, having that inflection point allows both sides to evolve independently instead of one tool having to do everything like end to end.
Yep, totally makes sense. I think the declaring the having that flexibility point was kind of the piece I was looking for. So thank you.
Yeah, I'm sorry, not maybe it's a dead horse, but like we have replica sets. You just change the count, and all of the mechanics of doing it are hidden behind you, but that changing the count is a nice API.
Yeah.
Interesting.
I have questions about process, if we can jump to that. If we, I'm kind of imagining we're all sort of sitting here shaking our heads, yes, saying like, okay, this sounds like we're all kind of thinking of the same thing, at least vaguely. To begin work on this, I imagine this is sort of a proposal style exercise we're going to be going through. What does that process look like, and how would we start making formal proposals of what an API might look like one day?
So I think Jacob has started working on what part of the API might look like, and he's writing it up in the Kubernetes style with Go structs. And we've been trying to get some initial feedback from some people inside of Google, like Tim Hawken, who have a lot of in-depth knowledge both of Kubernetes and of trying to write sort of cloud provider abstractions. So Tim has been closely involved in the ingress work and in the volume work, which are both places where we've tried to create generic interfaces that have very sort of different implementations. And so I think the next step is to take that and turn it into a PR against kubedeploy, and get some initial feedback, but get something checked in that we can agree is enough of a straw man that we can start writing code around to test it out, and iterate from there.
Okay, I think that's a great idea. Any idea on the ETA for a pre-alpha version of an API?
So for one of the things that we did early on was distinguish the fact that this is kind of a massive effort, and there seems to be one overall concept of defining your control plane and all of that stuff, and then there's this separate concept of how do you define nodes. And so I've been heads down looking at the node side, and Chris Rousey has been ramping up on what should the control plane definition look like. So for at least for the nodes portion, I could have a PR later today. In fact, if we have time in this meeting, I can go through some slides of the way I've been tackling it and how I've been thinking about it and what it looks concretely like today. But yeah, for at least the node portion, I have something that is interesting enough to discuss, I'll say, that I got a PR later today.
I think going through the node portion would be helpful, especially because we have everyone on the call.
Yeah.
Maybe to kind of poke holes in it. And then one thing in the name of the control plane that I wanted to mention was we had talked about it being almost a one-to-one mapping of KubeADM moving forward. So I guess there's a possibility that there may not be much work from us on that front as well. But yeah, anyway, I vote going through the node stuff. Anybody else?
Yeah, I mean, if there's anything else that other people want to discuss first or wanted to get out of this meeting, ask now. Otherwise, I could just immediately launch into my other set of slides.
I will just mention that as far as the cluster API goes, I hope to get a straw man out in a PR for everyone to review sometime late this week. So that's a general ETA for a discussion starting point on that.
As soon as we have an alpha something, I'm going to try to glue that into Kubicorn, so we can at least start playing with it.
Okay.
Yeah.
All right, that's all I have.
I have one thing I'd like to ask before you dive into the technical. So on the multi-cluster side, there's been effort to create a cluster registry, both for discovering of clusters that are available to a given organization, and also for federation to know like which clusters to target. And I guess I'm just wondering, like, is there any overlap here? It kind of seems like if you're using this cluster API to, manage your clusters, that would be an easy entry point for discovery for the class of users that just want to use a cluster registry for that use case. And maybe would, provide a way for federation to ignore a lot of the details and just, point to the clusters that are managed using the cluster API. I'm just curious if there's been any discussion with the multi-cluster team around this issue.
Yeah, so early on when we were brainstorming scope, and as people have brought up, like scope is so important in this project, so we don't just boil the ocean and take forever to actually deliver something. We were doing a lot of brainstorming about, do we want to completely subsume the federation effort? Do we want to be able to have a single control plane house the definition for multiple clusters and allow you to reconcile remote clusters and have like one master cluster that's actually doing the reconciling across many different clusters? And then when we found out about the cluster registry project, it seemed like a really nice delineation of concerns would be the cluster API for a single API server that's housing definitions for this. It really simplifies things if you say it should only house the definition for a single cluster, and that any sort of aggregation you need across clusters should use the cluster registry, so that it just has really nice semantics. If you need listing, use the cluster registry to first discover all of the clusters that you care about, and then once you connect to them, then you can use the cluster API to actually actuate each one of them independently. And that decoupling, I think, really simplifies things. But if there's a really strong need to revisit that separation, like this is the time to bring it up.
No, I'm just ignorant. So I was just curious. It sounds like cluster registry is still useful, kind of as like a more of an index than anything. And then if you actually want to do work, you go down to the cluster API. Okay.
Yeah, and if you want to write a controller or a tool that is multi-cluster aware, I think it's reasonable to say here is the endpoint for my cluster registry, and you use that to discover all of the clusters, and then you actuate them based off of that, instead of having the cluster API attempt to do both scenarios or handle everything.
Okay, I wasn't clear to me that the cluster API is specifically like single cluster oriented. Okay, thank you.
That's a really good point though, because it wasn't clear to us when we started thinking about this either, whether the cluster API was a single or multi-cluster API. And I think, as Jacob said, we've fallen on the side of single cluster API because it's a lot simpler, and because there's another group of folks that are actively working on the multi-cluster use cases. And Chris asked in chat if we implicitly create a registry by doing this. And I think the answer is not exactly. I think we can, if a registry exists, we can automatically register into an existing registry. We could, if we wanted to, like specific deployment tools could create a registry inside of the cluster, right? The registry right now is implemented as a pod that you can run in a Kubernetes cluster. So we could, Kubicorn could spin up a cluster, install the cluster API, and install a cluster registry inside that single cluster. But I think there are also going to be use cases where there's sort of an external cluster registry, and you want to create your cluster and register it with that separate registry as well.
And a bit of an open question that I think is a little implicit here is, if we're doing a Kubernetes style API, where do these objects actually live? And for the node portion, for all of the use cases I've been thinking through, I think it makes a lot of sense for them to live in the cluster where the nodes are supposed to exist. It allows you to actuate them on the cluster itself. You can just kubectl apply or kubectl edit and create new ones. It allows you to run the cluster autoscaler there. But there's another problem if you actually host the definition of the control plane in that cluster. And we don't have a really solid answer for that. But if the controllers that are trying to reconcile that state just generically point to an API endpoint, that gives us the flexibility of either housing the definition for the control plane in the cluster itself, which might be completely safe to do in like an HA environment where you have multi-masters, and destroying one master doesn't mean that you completely lose access to the control plane. Or it allows you to house them, the authority of what your control plane should look like completely off of the cluster. And it gives you that flexibility without having to bake it into the actual API where these objects should live. And that might be a safer operation, just in case you accidentally completely wipe out your control plane. You don't prevent the reconcilers from being able to even access what the control plane should look like to be able to fix it. But I don't think that we have that same problem necessarily with the node portion. I don't know if that was actually implicit or if I was just reading into things too much, but I just want to call that out. Cool. So if there aren't any other questions, I'll just steam forward. Interrupt me all you want. Let me screen share again. Let me figure out how to screen share again.
Green button at the bottom.
Yeah. So. Okay. So the naming for the, first of all, can everyone see the slides so far?
Yeah.
Yes.
Cool. Yeah. The naming for this has been tedious, and it's gone through a lot of revisions, and will probably continue to go through revisions. Right now, I'm just calling these machines. We already have the concept of nodes in a non-declarative way in Kubernetes core. And so we kind of want to introduce the concept of how do I create a new node with a specification. And so I'm just calling a declarative node a machine, and I'll go through the specifics of that, skip through a few things. Well, actually, maybe we should go through these 10s because this is this kind of important context. So for the overall cluster API efforts, and also for this machines API, we've strictly said we're not trying to get into Kubernetes core. As Robert said, like the precedent has been set that core Kubernetes does not care about machine management, and there's even been a proposal that was turned down to try to add a concept of a node pool to Kubernetes core. And so all of this is going to be strictly outside of Kubernetes core. It's a little TBD whether these will be API extensions or using API aggregation, or if there will be custom resource definitions. We definitely want it to be Kubernetes style, but we're not trying to get this into the actual Kubernetes code base. And also, as a general goal, we're trying to separate out, in order to maintain portability, it's important to call out what types we think are reusable and shareable across clusters in completely different environments versus the types that are strictly tied to exactly one provider and versus the types that are strictly tied to a specific cluster. So just being clear about the portability needs and considerations to take in with different levels of the API. And so I think Cole called out, like, what are we actually trying to solve? What are our use cases? And since I'm just focusing on nodes right now, the priorities here are a little in flux. We're trying to get a better understanding with our PM from the Google side, what we think we really want to deliver this quarter versus what we should ultimately have in scope long term. So just going over a few things. Node creation, super simple. So given some form of template that somewhat describes your node, can we create a new node? And can we delete nodes? Specific node deletion is important for a few tools, like the cluster autoscaler doesn't just want, let's say we have a notion of a node pool, like a group of nodes with just a number to scale up how many instances you want. It's not really powerful enough for something like the cluster autoscaler, which actually wants to look at the workloads running on specific nodes and target the ones that are nearly idle and delete those specifically, instead of just generically saying, well, I want a few fewer instances, please randomly delete them.
And does that also include draining nodes? Or like, maybe you could talk a little bit about does it just make it disappear, or what is the integration that we foresee the users seeing?
A little TBD at this point. Presumably it would drain. I don't know if that should be, so right now all of our draining code, as far as I understand, is client side. It's baked into kubectl. It's baked into other clients that want to specifically evict pods from nodes before they're taken out of service. I don't know if that should be automatic in this API, but we at least need some form of, I would like to delete this node. So it could be the responsibility of whoever is deleting the node to first evict all, like mark it unschedulable, evict all of the workloads from it, and then delete it, or have that be part of it.
Yeah, I mean, right now that code is duplicated, right? Like Jacob said, it's in kubectl. Like the cluster autoscaler also unschedulables and drains nodes before removing specific nodes too, as does the GKE resizer. There is an existing issue to move drain into the server. And so I think that as we go here, we're gonna try to bump the priority of that issue and or help implement it, because like other things that started out in kubectl as client-side code, like the draining should really be done server-side from the Kubernetes point of view.
Is there community reaction, thoughts on that? Like, it seems reasonable to say that, deleting a node should also be able to train it first and then delete it, and then support the force, no, do it real quick, no wait, delete now kind of style. But if that's or maybe we just continue, sorry.
You have that flexibility now. Let's assume that deleting a node actually just rips it out of existence as soon as you say, I want this to be deleted. You have the flexibility of first, maybe in a workload aware way, or in just a generic, I want to evict all the pods first way. You can do that, and our API doesn't necessarily need to represent that. But if we build in the behavior that you always safely evict, then it removes that flexibility. And I understand that we could have the strategy of how to delete baked into the API, but you still have a lot of flexibility if it's just rip the node out of existence when we call delete.
Just an observation here. You're in the node on the machine, you're sort of assuming that it's going to have an OS image and a Kubernetes version. Is there a thought here that you would also count more generic machines that are used as part of a Kubernetes cluster, such as SIG instances? Because we've kind of faced the problem that when standing up a cluster, it is not just a kubelet machine and a cluster controller machine. You also, as part of a cluster, need to stand up etcd. We're also, in our case, using Vault for standing up cluster PKI. So we would really like to refer to all machines in the same way, because otherwise you start having to differentiate the way that you refer to an etcd machine from the control plane, from the nodes.
Yeah, so I was definitely thinking that nodes would have this notion of a role, which is already present in a lot of deployers. Kubicorn has this, Kops has this, where you say, I want you to create a node, and this is strictly a master node, or this is strictly a worker node, or it's master and worker, so you should be able to schedule workloads on it. So do you run machines that you don't want the rest of the control plane on, but you still want to say, I want exactly etcd on this, but I also don't want kubelets?
Exactly. Yeah,
okay.
It's just kind of for consistency. Otherwise, you have to start dealing with those instances in a completely different way. From a consistency perspective, it wouldn't make a lot of sense. I mean, the current work we've done in Tarmac uses that. Yeah, sorry if I'm jumping ahead. You've maybe got this coming, but
no, I'm actually really interested to drill into your use case. So you have an etcd machine, and are you running etcd just as a systemd process? I think most people running Kubernetes run etcd inside of a container, which means that you would also be running a kubelet on that machine. But it sounds like you guys aren't doing that.
No. We just because our experience is kind of said that actually just running it through standard systemd is actually the most well understood, particularly if you're trying to debug it. And we're running those on dedicated machines as well.
Interesting. All right, thanks.
Yeah, that's really interesting. A few initial responses to that, which is the way that the API is structured right now is we could continue to add these, enumerated things that we think would be these enumerated roles that would potentially have use across different environments, and one of them could be important enough or significant enough to say, I want an etcd only node, if that's a pattern we think that's going to be generally reusable. The other thing is that I think, as Robert said earlier, like the power from this API comes from the ability to actuate after deployment. And I don't know if, as an operational thing, using the standard set of tools to be able to operate on Kubernetes nodes, if you'll want to be able to take that etcd node out of service or add another etcd node. So another potential way to tackle this is you can still have a completely custom installer that says, in addition to all these worker nodes and the normal master nodes, I know how to create these other hosts that are etcd specific and don't have kubelet, and I'll just create those as special snowflakes. And then later on, I can still use the cluster API and other existing tools to work on my strictly speaking worker nodes, or to upgrade my control plane, or all these other things, but maybe you won't get the full value of the cluster API for those etcd nodes. That's just one other way of looking at it.
Yeah, and I think in that case, that would probably be something we would sign up to. We would have a more dedicated controller that might be responsible for instance, for doing rolling upgrade of etcd itself. But yeah, I'm just thinking that kind of is, when we're thinking of a cluster, I'm just trying to think of the other roles that might play a part that you would want to deal with in the same way. But yeah, I mean, I recognize it's probably more specific.
No, but it is a really interesting use case. One of the other factors that we've been conscious of is not only do a lot of people want to create a cluster, but they also want to create a whole lot of infrastructure around it to support the cluster's needs. And so we've kind of been struggling to draw the line for where this specific API should end, and you should start just opting into other better tooling for those purposes. So I think the last thing we want to do is accidentally re-implement Terraform, which allows you to create completely arbitrary cloud resources, and is really good at doing that. But those resources might be completely orthogonal to bringing up your cluster or maintaining it over time. So I don't know exactly where the line is drawn, but that's definitely something we want to stay away from, I think.
Completely agree, and I think we've been faced with the same challenge as well. Like, where does the line get drawn? So yeah, really happy to kind of see where it goes, where we should stick to using resources in the cluster API versus actually it's just sitting outside in our own code base.
Cool. Any other special considerations for? I thought this would be like just breeze right past this slide, but no, this is super interesting stuff. So anything more specific for node creation or deletion? Any specific concerns?
Yeah, I'm curious. What does node deletion look like from the perspective of a declarative API? And is that something like, are we imagining that all of the nodes are listed one by one individually in this cluster API? Or is this just something that's called out from like an all-around ecosystem needs to be able to do individual node deletions?
So at this point, at this slide, it was like all around, we should have this ability.
Okay.
To give you a brief preview, when we were originally brainstorming on how to represent nodes, we started with the concept of grouping. It's so natural to say, I'm probably going to have a lot of nodes. A lot of them are going to be homogeneous. I probably want to be able to scale them up and down. And so we just started with node pool or node sets, or some way of saying I have a template and then I have a number of those. But based on a lot of feedback that we got, we think it's more important to really focus first on how do you define a single node. There still seem to be strong use cases for, I just want to experiment with this one-off node and I don't necessarily want to create a whole set that is just size 1. And so this is absolutely up for debate, but the way that I've been thinking about it so far in the API is to have an API object that declaratively says, I would like a node to exist and I would like it to look like this. Right now, the concept of nodes as an object exists in core and they have a spec and a status. The spec isn't really declarative. You can't just say, it reports the version of the kubelet that it's running, but you can't just say in the spec, well, I'd like to run this version and have it upgraded. So if you imagine a node as it exists today in core as an entire status of the kubelet, I want to create a new object that is actually the specification for that. And so if you create one of these, it's kind of like you can create a pod. At first it's unscheduled, and then it ultimately gets scheduled to a node. And you can delete that pod and it gets unscheduled from that node. You can create this declarative, I'm just calling it a machine at this point. You create a machine with the specification of what you would like a node to look like. And then that node should come into existence if you're in an environment where they can be auto-provisioned. And then if you want to delete that node, instead of deleting the node object, you delete this declarative object, which is the machine, and then the underlying controller should take care of deprovisioning the node, which then gets unregistered. That's how
right. So just to be really crisp, to kind of clarify, if I have 2 node pools, each with 50 nodes in them, you're implying that I'm going to have 100 different machine objects then expressing the description of each one.
That was my current thinking. That doesn't forbid us from also having the concept of machine set, which makes them much more manageable. And so it would be, the relationship would be very similar to how you have pods and replica sets.
Right.
You have machines and machine sets. And so if you don't care about the individual management of every single machine, you can just create a machine set and then scale it up and down. But under the covers, that might be translated to 100 different machine objects, just like
right.
that with 100 pods or 100 replicas is going to actually create 100 pods for you.
Okay, makes sense.
Cool. Anything else on this slide?
I have a question about node creation.
Yes.
One of the things we see a lot in Kubernetes, and we saw this in COPS, was users who want to bring their own aftermarket logic while bootstrapping a node. A really simple use case is I have some security tool that I need to yum install before I can run Kubernetes pods on this node, whatever, right? Some arbitrary logic that like user or systems administrator would want to run. We turned our nodes down to it in COPS and said it was an anti-pattern. We do support it in Kubernetes. And my question is there a place for that in the node API, or is that a controller level concern that we don't care about at this higher level abstraction?
So I thought COPS had the concept of hooks at this point, and the hooks would run on nodes.
There is hooks, that's right.
And I'll throw out like compute engine VMs have the notion of startup scripts. And so this is a really common style of thing. I mean, I think my take would be we should enable you to pass such blobs to the controller. Is it worth having a standardized mechanism across all controllers to support that functionality? That's a fair question too.
Right. Like on one hand, it could be up to the controller to sort of care about what the actual implementation of bringing up a node looks like. And then on the other hand, we could actually have a blob that we could define that says, go run these, bash script, these bash commands in order or something.
Yeah, I'll also mention that on GKE, we also sort of turned our noses up at that pattern and said that we aren't going to support node-specific startup scripts, and you should use daemon sets instead. And that we initially got some pushback from customers, but recently people have not been asking for startup scripts anymore for node customization.
Is that applicable here in the sense of, like, we do have the difference of as a service and more standardization trade-off versus more flexibility. And so I don't know. I want to say, like, it's not clear that that's a decision that carries over without re-looking at it.
Yeah, I agree. I'm wondering if it's one of those things that you don't put in the top level API to start with until there's specific demand for it, and consider the concrete use cases as opposed to we think people might eventually want to do this.
Yeah, so,
I mean, I have concrete use cases. They're in the COPS and KubeAccord issue tracker.
Excellent. I will look at those. I will do a quick time check. We have 6 minutes before the meeting is scheduled to end. I propose we try to get through the other 3 slides on capabilities today, and then Jacob send a PR with the actual API struct definitions rather than trying to do those during this meeting, and we can review them next week.
Cool. Okay, so the concept of what an OS image is could be different in different environments. If you're in the cloud, maybe this is a single string. In GCE, we actually have this like nested structure to define a single OS image that actually has the project and family and an ID. And if you're on premise, your concept of an OS image might actually be more like, I'm using Debian at this version and maybe some other metadata, but on a per node basis, again, kind of, if anyone feels strongly that this should be on a per group basis or shouldn't even be considered for this API, it seems useful to be able to actually upgrade nodes. And that could be, so we want, the way that I'd phrased it here, we want the notion that I want to upgrade this node to be declarative, but the way that gets actuated could be different in different environments. So if you're in a cloud environment, the controllers that you've set up might just strictly delete and replace the node with a brand new node conforming to the new spec, and that is bound to our declarative notion of a machine. Or if you're on premise, it could just be actuated by apt-get upgrade or some other in-place installation that doesn't actually replace the node. But as a capability, upgrading the operating system for whatever definition that is in your environment seems useful, independent of being able to upgrade the Kubernetes version, which would be the actual kubelet that's running. Ignoring the control plane at this point, just the kubelet and maybe container runtime on a specific node. Anything on that before I go to the next slide? Actually, let me blast through just the next 2 slides, and then we can come back if there are any questions or comments. So kind of alluded to this. Very similarly, being able to specify the container runtime that you want to use and its version. So I don't know how big of a use case it'll be saying I want to switch from Docker to Rockets, but certainly being able to say, I want this machine to run Docker at this exact version, and I would like to be able to independently upgrade that in a rollout fashion, node by node, without affecting the version of Kubernetes or the operating system image. I put this as a lower priority because this is something you could achieve by baking a new OS image if you're in the cloud. Just have it pre-bundled in the operating system image instead of having it called out as a separate field. But it seems like really useful functionality to be able to rev container runtime independent of kubelet, independent of operating system. And as a super low priority, this might be addressed with the concept of bootstrap scripts, or might be useful from an overall, like, what does Kubernetes look at like as a distribution? But we could use the same sort of, if we're already versioning the kubelet and the operating system and your container runtime, what if we extend that to be any important software that you care about to be on the node, so that you could apply a critical security patch to OpenSSL without having to bump the version of Kubernetes or use a completely new operating system image. You could just say, yeah, I need this new version of OpenSSL, and it's probably something you could do as an in-place upgrade, but you could do that declaratively in the API. I'm not calling that out as super important to deliver immediately, but just how I've been thinking about the evolution and where this could go in the future. And then autoscaling is an interesting use case that we brought up. After talking with other people in Google last week, I think this is a less important thing to immediately focus on. Certainly, I think the project wouldn't be as successful if we couldn't eventually rebase the autoscaler on top of it, but we already have autoscaling for a lot of different cloud providers. It's not new functionality that we're enabling. It just gives us kind of a better, consistent view of nodes. So, but if we want to tackle autoscaling, they have these concrete requirements of being able to do accurate predictions. So instead of just saying, I want this instance type and I would like several more machines of it, and then once they come up, I'll then figure out how much memory they have and how many CPU cores they have and how much disk they have, to be able to actually predict ahead of time, if I scale up this set of nodes or create this new node on the fly, what are the capabilities it will have afterward, so that I know that I should scale up this kind, or I should scale up 10 of them instead of the first one and then wait to see that that doesn't actually fulfill my requirements, scale up another one, wait for that to come up. Just being able to predict how many you need to scale, of what kinds. And then there's a lot of price modeling in the cluster autoscaler right now, where they have a weighting mechanism to look at the different kinds of machines and actually figure out what is the cheapest way to scale the cluster for the pods that I need to scale right now, instead of just being completely ignorant to cost and scaling up what looks like a good machine. You could actually have these weighting mechanisms to say, I'll try to use the cheapest machine or the most efficient machine in this case right now. Okay, so I breezed through those and we only have a few minutes left, but anyone want to add more top-level capabilities that they really feel strongly about, or want to drill into any particular one of these and discuss their needs?
The very last one seems like a huge, seems like a scope creep or something. What's the impact of this? This seems like more like an action item for cluster autoscaler itself rather than the cluster API. I mean, is the cluster API going to include these price estimates, or?
So I can get into, there's a lot of technical details there. The way that I was thinking about it was making sure that we wouldn't build any sort of pricing into the node portion of this API, the machines API, but make sure that we support all of the provider agnostic inputs that they need in order to be able to model the price in the way that they do today. Otherwise, it's kind of a hard stop from them, that they'll never rebase on top of this API unless we support these inputs. They can completely own if they need to make additional APIs on top of the machine API, or if they need to build additional tooling on top of it. But my thought on this was just making sure that we could strawman and have the inputs to their pricing models.
Okay, I got you. I understand.
Cool. I think we're at time. If there are any other concerns, reach out to any of us. I think the best place is probably, well, we can certainly wait until next week's meeting, but I think conversation is still going on the Cluster Lifecycle mailing list or in our Slack channel. Certainly reach out to any of us individually. I'm going to stop sharing my screen. There we go.
Yeah, I think Slack is the highest bandwidth to continue the conversation. If people feel like we need another meeting sooner than next week to keep going over some of these things, I'm happy to put something else on the calendar also.
Cool. Otherwise, I'll send out a PR with more context about the actual types and my thinking behind them so far. And I look forward to everyone's feedback.
Awesome.
Great. Well, thanks everyone for coming. Hope to see you guys all again next week, same time, and in Slack in the meantime. Talk to you soon.